Hello and welcome to this week's What Were They Thinking? We have a variety of news items to discuss this week, whether that's desperate attempts by governments at a state, local, and federal level in America to get people vaccinated, claims that if you're infected with the original strain of the CCP virus, you somehow have immunity for at least 10 months. Then there are issues with whether or not you can actually know how well your cancer treatment is going from a very simple blood test very quickly. There's new signs of microbial life in the ancient earth, weirdness with Australian animals showing what could be best described as unusual genitalia, and developments in materials technology to allow for better generation of electricity. The timestamps for these and other news items can be found in the description box below. Let's start with America's desperate attempt to get people vaccinated. There's about a 50% uptake rate in some parts of America's healthcare community, and in the wider population, it's not much better. We've already described in previous weeks how they're deploying clinics in a pop-up nature, anywhere and everywhere they can. This includes strip clubs, churches, schools, anywhere that will bring the vaccines to people rather than getting people to come to the vaccines. It appears even that isn't working as well as they'd hoped, as now they're offering to reward people for getting vaccinated by giving them cannabis. In a certain irony, Washington State is offering people cannabis for getting vaccinated, which is illegal at the federal level but has been legalized at the state level. This is intended to push Washington State's gross vaccination level beyond the current 70% of adults, and it works by allowing certain cannabis dispensaries to give one unit, a joint of cannabis to someone who receives their vaccination. The program's been given various names, whether that's joints for jabs or poke and toke. Other states have already tried similar programs, and in one, it was called Snacks for Vax. This should demonstrate just how serious some of the states in America are taking the attempt to get people vaccinated, and how much difficulty they are having in getting those vaccinations to people. The next piece of news is a combination. It both looks into the effect of combining two different vaccinations, that being the AstraZeneca and Pfizer, and whether or not certain countries are going to start doing so. Canada appears to have already approved this particular approach, and Australia is currently considering it. The general understanding is that if you have one of the vaccines and then the next for the booster, you have a better immunological response. You can also choose to use the Moderna for the second dose if you've received the AstraZeneca as the first dose. The reason this works is that all three are based on an mRNA technology. This means that there's no real issue with mixing methods and thereby disrupting the process of being vaccinated. Australia faces the same problem with this that other countries do, and that is, even if they wanted to roll out such a program, they don't have enough access to the necessary vaccines across all varieties to offer it. The research is based on a relatively small Spanish study, and that looked at 600 people who received one dose of each of the different kinds of vaccines, primarily focusing on the AstraZeneca and Pfizer combination. What they found was that the mixture of two vaccines gave a better antibody response. There are now several other studies coming into play, and these have slightly larger cohorts. One in the United Kingdom, for instance, has 800 people, but these are still relatively small studies, and the data drawn out of them could be beneficial, but it's unlikely we'll ever see the same sort of large-scale clinical trials as you need to get these drugs approved in the first place. Next is a piece of news still looking at immunity, but this time a Cleveland Clinic study which claims that if you're in a situation where there's a shortage of vaccines, priority should be given to those who haven't been infected yet. They believe that if you have been infected and recovered from the CCP virus, you are unlikely to develop an infection a second time, and therefore giving the vaccine to those who have been uninfected is more important. This does have several problems with it. Not the least of these is what about the new strains, particularly those coming out of India, which appear to be able to reinfect people who have already been infected by the original Wuhan strain of the CCP virus. The Cleveland Center study has at least substantial numbers behind the conclusions reached. It involved a little over 52,000 employees. A little over 2,500 had been infected, and 53% had not been vaccinated. Over the 5 months of the study, the 1,359 people who were involved who had already been infected by the CCP virus did not get infected a second time. The Cleveland Clinic does state that they believe that this is an appropriate measure to take if triage is necessary and prioritization of people with a limited stockpile of vaccines. They do then state that if there isn't a concern about a limited pool of vaccines that need to be distributed judiciously, then anybody who is eligible should go get themselves vaccinated. Going now from the CCP virus to a new disease, or at least one we haven't covered recently, dengue fever. The method behind reducing the spread by 77% is relatively simple. They introduced mosquitoes infected with a bacteria that made the mosquitoes then resistant to carrying dengue fever. Dengue fever is spread as a virus through mosquitoes, specifically female mosquitoes, as they move between possible new hosts and draw out blood from them. It can affect up to 400 million people each year, and it's not an insignificant problem. In many ways, it's similar to malaria, except malaria is caused by a parasitic organism rather than a virus or bacteria. Since, like other diseases, it needs to spread via mosquitoes, if you can curtail that particular vector, you can drastically reduce the number of infections that occur. Reducing infections has a compounding effect over time, as every time you reduce the number of current carriers of the disease, you reduce the number of people who are able to spread it to mosquitoes and then to new hosts. Unlike some of the concerns raised with genetically modified mosquitoes which are either sterile or would undergo death shortly after being born, the use of the bacterium in this case has almost no risks to speak of. Having looked at a trial of stopping the spread of a disease that uses mosquitoes as its vector, we can now look at another trial, and it was examining whether or not you can find out how effective a cancer treatment has been, almost in real time, using a blood test. More often than not, it takes quite some time to figure out just how much effect chemotherapy and other cancer therapies are having. The reason for that is quite simple. It takes time for the chemotherapy drugs to find their way to where they need to be and begin having their effect. The effect primarily is to slow down the growth of the tumor, which then allows time for the immune system to be active against the tumor and begin attacking it, or if need be, have surgical interventions, radiation therapy, and other more direct interventions. One thing you can measure is how much of the tumor is circulating throughout the body, that is, cells that are broken free from the tumor site and are in the blood. This can also be what causes the tumor itself to metastasize. The problem you have is that not all tumors will have this process, and in fact, not having it is very desirable. You then don't have a means of measuring the tumor directly. What you can instead do is measure for what are called extracellular vesicles. In the case of cancer cells and most other cells in the body, these are released when you start damaging the cell walls, such as when you're being given chemotherapy. This has allowed researchers to develop a system that can give results in as little as 24 hours of being given chemotherapy as a treatment. That allows for almost real-time monitoring of the tumor's treatment. By monitoring it carefully, they can then modify the treatment as required, which can either improve quality of care or better provide treatment by either increasing or decreasing doses in response to how the body is handling the treatment. Next is the approval of the first Alzheimer's treatment in 18 years. We previously mentioned that the company behind this was seeking approval, that being Biogen. They had promising results in all their clinical trials, and they were going to try and get it approved. Well, they've done just that. It's being sold under the name Aduhelm, and it's meant to try and break up the plaques in the brain that cause Alzheimer's disease. The clinical trials so far have demonstrated that it does reduce the number and nature of the plaques in the brain, but that doesn't lead to improvement in memory and cognition. This means that it might be possible for the drug to be used to halt the progression of the disease in its track, but it won't bring someone back to where they were beforehand. Since you have this odd situation where you might not have any improvement, but you're not going to get any further regression either, the FDA has approved it under a particular pathway. It is the special accelerated pathway that exists for a particular unique set of circumstances where the drug's likely to have a benefit for patients, even if it's not known how well it will work. This particular option was chosen as the FDA Advisory Committee back in November stated that they did not believe the company had shown the drug was effective in treating Alzheimer's. Given the company's belief that they have shown beneficial results, the committee's disagreement, and the FDA's desire to see benefit for people with Alzheimer's, they opted for this particular option. Whereas they might have chosen to either refuse approval full stop, or they could have approved it as a drug going to market. They've gone with what you could call the middle ground. When you consider that Alzheimer's is otherwise relatively untreatable, a drug that might be able to at least halt the progression of the disease is substantially better than no treatment at all. It means those who are in a bad state won't get any worse, and those who are in the early stages of Alzheimer's won't progress to a point where they have no idea who they are, where they are, or what they're doing. Next is another drug that's been approved by the FDA, and this one's for weight loss. It's been many years now since the FDA has approved a weight loss drug. This owes to a variety of issues. Most of them don't have very effective evidence to start with. Those that do tend to have a lot of side effects and complications associated with them. It's why the general argument has and will continue to be having a calorie deficient energy in and energy out equation is the best way to lose weight. In this case though, sometimes people need to use a drug to help them lose weight. The one in question here is from a Danish pharmaceutical company called Novo Nordisk. They were also responsible for manufacturing a lot of the insulin for Europe and influenza vaccinations. The drug itself is called semaglutide. Given Novo Nordisk's work with insulin and the fact that it's a direct treatment for diabetes, it's no wonder that this drug came out of their research in that area, where it was being used as a treatment for diabetes. Their published research claims that in a cohort of 2,000 obese adults from 16 countries, that they had a 15% weight loss on average. They found that about 30% had more than 20% weight loss. That's a rather large figure for any study that's looking at weight loss in general, let alone from a specific weight loss drug. If you were hoping now that it's been approved that you'll have ready access to it, unfortunately, no. The FDA has approved it for weight loss in adults who are either obese or overweight and have at least one related condition such as high blood pressure, type 2 diabetes, or high cholesterol. It's unlikely to ever find its way to being readily available on the market. That's not a bad thing, with the fact that this requires weekly injections of the hormone. This then acts over that week and then needs to be refilled, let's say. Further to that, all of the trials involved not only use of the weight loss drug, but a diet, which means it's unlikely to ever resolve anything for anyone who's not willing to go on some sort of diet on top of taking this drug. Oh, and one more thing. Given that this is America, you're likely to pay somewhere around $1,300 a month for this particular drug if you don't have insurance. Going from America and its land of the obese, we instead go to the ancient Earth and are looking for microbial life. When you look at the development of the planet, you might think dinosaurs, but if you go back even further, you might think early plants. Even further beyond that, you need to start looking at things like algae and plankton. These are what can generate the oxygen needed for larger organisms to then live. Deep mines can often give access to samples of what the world is like at this time, and that's what's been found in Sweden. A mine there has gone down far enough to be able to start finding evidence of ancient microbial life that goes back more than 50 million years across 30 different sites. The challenge has always been with this sort of research, finding fossil evidence. When you're looking at something smaller than a pinhead, it's very hard to figure out just what is a fossil and what is simply random conglomerations of something in the ground. This is why you start looking for proxies. The most common proxies being a chemical or molecular signature. These are often in the form of a notable isotope that is generated by biological life, and that's what they're looking for several kilometers below the ground. The challenge with this research is that you have to infer some of the final conclusions, and that's largely because you're looking at evidence, finding the appropriate biological pattern that generates it, and then fitting it into the geological layers that are there. That is, if you see the same evolution of particular processes represented in successive layers of the ground, and that these geological layers line up with the changes in the microbiological organisms and what they're doing at those times, you can be fairly confident that the changes are related. That's something that's extremely difficult to do when you're looking at samples that come from kilometers below ground level, and often have to rely on almost entirely chemical or biochemical analyses. Going now from one example of ancient and disconcerting microorganisms to a very old, but not quite as old, microorganism that's been revived. A 24,000-year-old creature has been brought back to life from deep under Siberia. No, this isn't the opening to a horror film, but in fact the badeldoid rotifer. These are tiny animals that, much like tardigrades, can survive extremely harsh conditions, like those found in Siberia. Russian scientists claim that they were able to have the creature reproduce after being frozen for these thousands of years, and this 24,000-year gap well and truly exceeds the 10-year record that was previously held. The information contained in these studies, although sounding initially terrifying as a way to wake up the dead, and diseases, and all sorts of unpleasant things, could have implications for things like cryopreservation. How do you preserve someone or something for an extremely long time so that they can then be revived at a later date without many of the lingering issues we have at present, where the 24,000-year-old creature underwent parthenogenesis, or creating its own offspring via itself? A single bee has given rise to hundreds of millions of its own clones. A slight improvement, but then again they've had far longer. The South African honeybee is perhaps one of the more well-known bee species. They were at one point exported across the world to make up for countries that didn't have adequate bee populations. Once there, they expanded greatly, and this led to the current preference or prevalence of the South African honeybee. Over a period of about 30 years, one individual bee can make millions of copies of itself. They are effectively clones as it goes through parthenogenesis, asexual reproduction, and this means that the parent and offspring are almost entirely identical. There is no requirement for a second partner, let's say, to be involved, and this means that they can keep producing offspring, something essential in the case of a bee colony, where all the workers are female. The males exist purely for reproductive purposes, and the queen makes more workers, and occasionally new queens. This is where one particular colony comes in. It's been undergoing parthenogenesis since 1990. The reason it hasn't suffered some of the effects of other inbred lines, the royal family of Britain for example, is simply because it can perfectly replicate its DNA and it doesn't undergo the mutations that occur in other particular inbred lineages. This means that with a perfect reproduction record, they can keep going and they don't suffer the effects. While still on the topic of animals, or at least insects, and sex, let's talk about Australia and echidnas. If you weren't aware, Australia is full of things that want to try and kill you. And if it's not things, it's animals, the weather, people, animals, parts of the environment, more animals, and just about everything else. And if it isn't trying to kill you, it's weeding you out. For example, platypuses glow in the dark. They also have a bill, lay eggs, lactate, the males have poisonous barbs in their hind legs, koalas have chlamydia, and to get towards the top of the weirdness tree in Australia, echidnas have penises with 4 ends. Unlike a duck, which has not only a corkscrew-shaped vagina, but also has 7 of them, only one of which is functional. The echidna has 4 penis ends, and they will alternate between which one is being used. This allows the echidna to ejaculate 10 times without having to take any particular pause. Unfortunately, we can't really tell you why the echidna has 4 penises, nor can anyone else exactly explain why. It's thought that there might be evolutionary reasons for it, with how far back monotremes, which are the weirdness of echidnas and platypi, have diverged from other species like mammals, birds, and reptiles, but it's not entirely clear just yet. Going now from weird and disturbing animals to technology news. A new kind of silicone could be used to help in generating energy and better efficient energy devices. Think things like your phone when it runs out of power, laptops, tablets, and in fact any device that needs energy. By being able to better develop crystals made from silicon, you can then use the energy more efficiently, meaning batteries last longer. Consider at the moment the massive worldwide chip shortage. One of the reasons there's a chip shortage is that there simply aren't enough being made, and that's because chips rely heavily on a reasonably well-established failure rate of writing into not only the very complex chip itself, but the chip being embedded in silicon to allow for the efficient move of electricity through it. In order to get those highly efficient silicon bases for these chips, and for that matter other technology, developments like what we're talking about in this particular part of the video from Strobel's lab are needed. What they were able to do is create a series of repeating hexagons, the SI24 format, and these were synthesized. They created regular particularly oriented crystals, and then they could begin layering them on top of each other. This was called 4H silicone, and was so named because of its repeating pattern. If you can make silicone, which is the very basis for most modern technology, cheaper, more easily mass-produced, and more efficient, you're going to improve the efficiency and cost of just about every product in your daily life. The final piece of news is another technological item, but it regards carbon nanotubes. And not just carbon nanotubes, which are generally interesting of themselves, but the ability to generate electricity by scavenging it from the environment. This particular development could be extremely important in creating portable rechargeable devices that aren't reliant on something like a solar panel. The way it works is that the carbon within the carbon nanotube interacts with a liquid environment around it. This will pull the liquid through it, and it draws electrons out of it. This generates a small current, and that can then be used to drive a chemical reaction. In some ways, it's almost very similar to the way a battery operates. You have a solvent and some sort of ion in solution. The ion moves between two electrodes, one positive and one negative. As it moves between them, it moves the electric current, and this is what generates the power that you then use. This does almost exactly that, but doesn't involve the electrodes or the need for any kind of wires. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.